Hello everyone. In this video, we are going to discuss about the runtime environment in the compiler design. So for all the students who are preparing for the NIC exam, this particular topic is very important. This is clearly mentioned in your syllabus and you need to cover this topic. So we are going to start with runtime environment. In this particular topic, we are having two sub topics and we are going to discuss them one by one. So beginning with the first topic. So the first topic is about the scope of the variable. So whenever we are talking about anything which is runtime, we have to understand the scope of the variable. So scope of the variable can be dynamic or can be static. But before jumping into the dynamic and static scope of a variable, we should understand one concept that is called as free variable and the global variable. We should understand what exactly we mean by free variable and the global variable for say. So let's have one basic code. Let's say we have one integer x and we are having a int main, the main function, the driver code, and then the body is starting. Okay, and then let's say here we are having some printf statement and so on. So now we haven't defined anything here in the main with respect to x, but if I try to print x, x will be printed because here our x is the free variable. Our x is the free variable. So you can see if we talk about the scope start with the curly braces of the function and end with the curly braces of the function. But here if we are having free variable, that means it is having a global scope. It is free and it can be part of any particular thing, okay, or any particular function. Then the other type of functions are the local functions or the local variables, not local function, but mostly we call them as local variable. They are actually defined in one particular scope and they are used in that scope only. So while discussing the dynamic and static scoping, we should understand the free variable and the global variable as well as the local variable. So now we are going to understand the concept of the free variable and global variable with respect of scoping of the static and the dynamic concept. So static scoping, it means that printing the value of the free variable will give the value of the global variable. So it means if we are using the static scope, then whatever variable is free, it will be printed because it will be treated as the global variable. But if we talk about dynamic scoping, it is not so. If there is a variable which is free in nature, then first there will be calling of functions. There won't be any single function. There will be some set of functions under which we are going to print and do our stuff. So what will happen in the calling function? First we are going to check the value. Then if it is not present, then we are going to check it in the other function which is actually calling it. So there will be two functions, calling function, called function, and the main function. So the scope will go like that only. So let's say if we have something called as main, main for, let's say main is our calling function, and inside this we are calling one function f, and inside f we are having some set of variables and we are going to print something. And let's say there is some free variable which is defined outside the scope of the main body. So now if I am calling f function, first whenever I am doing the dynamic scope, everything is going to be checked within the boundary of the function f. If it is not defined there, it will go and check. Who will go? Compiler. Compiler will go and check the same in the main function. If it is not present there in the main function, that is the calling function, then we are going to check for the free variables that are having the global scope, which are defined outside the main. So this will be the order. So first we will go for local and then we will go for the global one in the dynamic. But in static, every time whenever we are printing the free variable value, it will give us the global value of the global variable. So let's understand the concept by one example. So here in this particular scene, you can see we are having one piece of code, and here you can see that int equal to 10 is defined as the free variable. This is free variable because it is not defined within the boundary of any particular function. So that's why it is called as free variable. That means it is having a global scope. Now we are having main function, and inside main function we are having two variables, a equal to 100 and b equal to 200, and then we are calling a function fun. Then inside the fun we are having a variable called as c, which is local variable, and then we are trying to print the value of a. So you can see A is defined in the main space as A equal to 100, and A is also defined in the global space that as A equal to 10. So when I'm going to print the value of print FA, what value will be printed if I'm using the static scope, and what value will be printed in my dynamic scope? That is the question. So as per our discussion, we understand that in the static scope, the value will be printed that is global in nature for the free variable. So here A equal to 10 will be printed, not A equal to 100 will be printed in the static scope, because it will print the value of the free variable. But if we talk about the dynamic scope, first it will check within the scope of the fun. It is not present there, A is not present, then it will go and check the calling function. Here fun is the called function and main is the calling function. So we will check in the calling function, and we got here A equal to 10. So it will be printing A equal to 100. Sorry, it is A equal to 100. So it will be printing A equal to 100. So from this, you can understand what we exactly mean by dynamic and what we mean by the static scope. So in the static, every time value of the free variable will be printed, and in the dynamic, every time the scope checking will be done, and according to the dynamic scoping, we are going to perform the printing, and the value of the particular variable will be assigned to it. Now, this was the part 1 in the runtime environment. Now, the second part of the runtime environment topic is the parameter passing technique. In parameter passing technique, there are 3 kinds of technique. One is called by value, one is called by reference, and the last one is the call by value restore. We have discussed many times the upper two, that are the calling by value and calling by reference. So in this video, I'm not going to make a detail about call by value and call by reference, but I will give you a slight introduction about these, and I will discuss in detail for the call by value restore. So what we mean by call by value? So call by value is the one where we are having the functions, and one function is calling another function, and during those functions call, we are only passing the value of the formal parameter and the actual parameter. So there will be 2 kinds of parameter, actual parameter and the formal parameters. So actual parameters are those parameters which are the original variables, and the formal parameters are those parameters which are defined in the brackets of the calling function. So these are the formal parameters. So if only the value is being passed, we call it as call by value. If we are passing the address, then we call it by value, call by reference. Okay. So if we are passing the address of the actual parameter to the formal parameter, then formal parameter will also behave as equivalent to the actual parameter. So here there won't be any difference, because we are passing the address, and now the manipulation which will be done over the formal parameters will be reflected to the actual parameter. But in the call by value, whatever changes are done in the formal parameter will not be reflected back to the original space, that is the actual parameter. Now, the most important thing and the point of discussion for our video is the call by value restore. So what we exactly mean by call by value restore? So here call by value restore is the thing which is defined in 2 steps, that immediate changes are not made, but the final changes in the formal arguments or the formal parameters will be reflected in the actual arguments. So it is saying if you are doing any kind of intermediate changes with the values of the actual parameters, they are not going to be reflected in the formal one. So from the actual, you are going to get the value to the formal. So during the intermediate, any kind of changes are there. If there is any changes which are made during the immediate, not immediate, but actually intermediate things. So whatever you are changing in the formal parameters with reference to the actual parameter will not be reflected immediately. It will be reflected only after the final execution. Now, how this actually work? We pass the value, but changes that are made to that values are actually restored. So this is the basic concept what we are doing here. Like we are passing the value from the actual parameter to the formal parameter, but whatever changes the formal parameter is doing to the value of the actual parameters are going to get reflected back. So that's why it is called as value are restored. So call by value restored. So whatever the calling will be done, that will be done on the basis of value, but whatever the changes are done, that will be restored to the actual parameter. So now let's understand this with example. So here we are having one question where we are going to discuss the output for all the three cases. Three cases means call by value, then the other case is the call by reference, and the last case is the call by value restore. Value restore. So now we have to understand these three things in details. So we are having this program here. We are having main, then we are having int a equal to 5, then a function test is there which is having the parameter as a, and then we are having one printf, and then we are having the body of test in which we are having c and d as the formal parameter. These are the formal parameters. Okay, here a and a are the actual parameters, and then we are doing some kind of manipulation. Fine enough. So the piece of code will change for the reference and for the value in terms of syntax, but what we are actually trying to put forward here is the concept. So don't think like when I'm going to discuss about the reference, where is the ampersand sign and how it is actually the call by address. So don't stick to the syntax thing. Just understand the concept, what is happening in all the three cases. So the very first case is the call by value. So in call by value, we know that the value will be passed. So when the value is passed, it is c equal to c plus d multiplied by 2. This is the first step. And what is the value which is passed in c? Copy of a. And in d also copy of a. So it will be 5 plus 5 multiplied by 2. It will be 15. Right? And then in d, what we are trying to do? We are doing d multiplied by c minus 3. So what is the value of d? It is 5 multiplied by, what is the value of c here? It is 15. So 15 minus 3. So it will be 5 into 12. That is 60. Okay. So we are having value of c as 15 and value of d as 60. Now, these all are doing the changes according to the body of the test. But now, once the execution is done and we are coming out from the scope of the test function, we are going to have the printf with the a. So now printf with the a will print a equal to 5. This will be our answer. We are going to have the value of a equal to 5 as our final output. So whatever I'm writing in green, whatever I'm circling in green, that is the final output. Because here in the value portion, only the values were being passed. Whatever the manipulation was being done, that was not reflected back to the original actual parameters because it was called by value. I hope you guys are clear till now. Now let's do it by the call by reference. So when we are going to do the same thing by call by reference, let's say c equal to c plus d multiplied by 2. So it will be 5 plus 5 multiplied by 2 and it will be 15. So the value of c is 15. Then we are going to manipulate the value of d equal to d multiplied by c minus 3. So now if I talk about the value of d, what should be the value of d? Value of d will be 5. Okay, value of d will be 5. It is not like that, because actually what is d? D is the actual parameters address and c has overwritten it. So now it will not be 5, it will be 15. Okay, and then the value of c is already being changed. So the names are different, c and d, but actually the value of a and the address of a is only getting passed. So we are going to focus on that. We are not going to see them as different. We are going to see them as same. So 15 minus 3. It will be 15 multiplied by 12, which turns out to be 180. So this will be your answer. So I will just mark a equal to 180 will be our answer for the case for value of pass by reference. So this will be our output. Here in this case, this was our output. So I hope you guys are clear till now. Then let's focus on the value restore. So I'm not going to do the calculation again and again. We are doing the pass by value. So when we are doing the pass by value, we are getting c equal to 15 and d equal to 60 as we discussed in call by value. So here in call by restore, what will happen? In call by restore, the things will be like intermediate changes are here done with the c and d and things were there. But actually c and d are what? A and C and D. C will be saying that I am going to take the responsibility of the manipulation of A. Now D will be saying that I am the one who got the value of A. So in call by value restore, if you are passing the same thing, many a times it happens that we actually do not know the output. So here in this case, your compiler can give you the output as 15, a equal to 15, or a equal to 60. So here you can have a equal to 15 or 60 as the answer. This is the call by value restore, because the values which are changed, that are C and D. What are C and D? C and D are actually A. So C saying that I'm going to have it as 15, and D saying I'm going to have it as 60. So whom to trust? So it depends upon compiler to compiler. So here in this particular case, you as human do not assure that whether it will be 50 or 16. So you are going to stick to the option that is a equal to 15 or 60 as the answer. So this is the classic example of value restore. And here you can have sometimes more than one output as well during different compilation time and during different compilation of the same code as well. In the different architecture or in the different compiler versions, you can expect different kind of outputs. So that was all about the runtime environment in the compiler design, and this is very important topic, but this is very crisp topic, and many a times small codes will be coming and you are going to decide the scope and you are going to decide the parameter passing technique, and these two things can be kept together and can frame a new set of questions. So these are very important, and you should focus more on these concepts for your exam.